Hey, 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 who's ready for some more polynomials? All right, okay, so we start to put a few things together from this unit now, and they kind of come together for us to be able to, you name it, factor polynomial expressions. So if your factoring skills aren't quite up to snuff for quadratics, that would have been from 20-1, it might be a good idea to go back and watch the video from the functions unit on factoring. It's just a side video that I've created. So if you can do that, if you're feeling a little weak on factoring, that would be a good idea. Okay, so let's take a look. First thing we want to look at is basically how these connect to each other. And this would have happened in 20-1. You would have talked about some terminology, x-intercepts, zeros, and roots. So if we have a graph of this function, f of x equals x squared minus x minus 6, the x-intercepts, you'll notice from this graph, are -2 and +3. Okay, the zeros of the function, see how we factored the function, x plus 2, x minus 3? The zeros are found by setting each of those factors equal to 0, and you would get -2 and +3. Look at that. So that's what zeros are, is basically when the function is set to 0. Okay, if you were to look at the equation, so same thing as we have here on the right-hand side, an equation, but equals to 0, well, that's pretty much the same as finding zeros, right? So it would have roots of -2 and 3. So moral of the story is roots, zeros, x-intercepts. When you hear that, that pretty much means the same thing. The x-intercepts of the graph are the same as the zeros of the function, which are the same as the roots of the corresponding equation. All right, let's look at kind of a new topic here, investigating the integral zero theorem. So we're going to learn about the integral zero theorem today, and then do some factoring. So first of all, the factors of the polynomial, yada yada, are x plus 8 and x minus 3. State the zeros of the polynomial function. So as we discussed up above, we set that to 0, then we would set each of those factors equal to 0 to find the zeros. So our zeros would be, isolate x, subtract 8 over, we'd have x equals -8, and x equals 3. There's our zeros. What do you notice about the constant term in the polynomial? So let's go back up to the polynomial. Here's our constant term, -24, and the zeros of the polynomial. What do you think? Looks like that the product of the zeros gives you the constant term, right? Or these zeros are factors of the constant term. So the zeros, which were -8 and 3, are factors, messy writing there, of the constant term. Okay, the factors of the polynomial, p of x equals x cubed, so now we have a cubic polynomial, minus 2x squared minus x plus 2 are, okay, so they factored that already, and we get those factors. So state the zeros of the polynomial function, and then what do you notice? So why don't you guys find those zeros and then unpause, and we'll see if we have the same answer. Okay, so did you get x equals 2 for a 0, 1, and -1? So what do you notice about the constant term and those numbers again? Well, once again, those zeros are factors of the constant term, meaning factors of 2 would be 1 and 2, or -1 and -2, and those comprise some of those. Just like up here, factors of 24, well, there's quite a few, but definitely 8 and 3 multiplied together give you 24. All right, so they don't have to be multiplied together, but they do have to be multiplied with something to give you 24, some integer. All right, let's look at the next page. Okay, so that leads us to what is the integral zero theorem. The integral zero theorem states that the zeros of an integral polynomial function, and you remember what integral was when the coefficients are integers, with a leading coefficient of 1, okay, that's a condition, must be factors of the constant term. Okay, so let's consider this one. P of x equals x cubed minus 7x minus 6. The leading coefficient is 1, okay, So that means we can use our integral zero theorem. So all of the zeros should be factors of 6. So there could be, the factors of 6 are 1, 2, 3, and 6. And you'll notice a plus or minus, right? Because you could have negative 1 times positive 6 to give us negative 6, or positive 2 times negative 3 to give us negative 6, okay? This list here are all the potential zeros, okay? The potential zeros of the polynomial. That doesn't mean the zeros are going to be all of those. They will just be part of some of those numbers. Okay, so let's take that polynomial, and it says list the potential zeros. Well, we kind of already did that. Plus or minus zeros of 6 would be 1. Okay, now other numbers that multiply 6, 2, 3, and 6, plus or minus in front of each of those. List the potential factors. Okay, so what they're saying is if we turn these numbers back into factors, so if x was equal to 1, if I turn that back into a factor, it would be x minus 1 equals 0, or the factor would be x minus 1. All right, so if we do that with every single one of those, we would have that. So x plus 1 would be another factor. Okay, why don't you guys finish the rest of those, write all of those potential zeros as factors, and then we'll look at part C. So pause your video. Okay, so these should be all our factors, x minus 1, x plus 1, x minus 2, x plus 2, etc. Okay, let's look at part C. So they're going to walk you through kind of the beginnings of how you would factor a polynomial. And they have two different students work on how they would do that. So Luke, he used the factor theorem, and he tried x minus 1 as a factor, so he put 1 in for x. And as you know from our last lesson, this should equal 0 if x minus 1 is a factor. So it didn't, so it was not a factor. So then he tried x plus 1 as a factor. So he tried negative 1 in for x. It equals 0. That's our remainder. So therefore, x plus 1 is a factor. So then he did synthetic division with that. So x equals negative 1 goes here. Carry that down, multiply, then add to get negative 1, and then multiply again to get 1, and add, okay, just from our last lesson, confirming we got a remainder of 0, but more importantly, we know this is 1x squared. Okay, it's x squared because we started with x cubed, and we drop 1 degree because we divided by x plus 1. Okay, so minus 1x minus 6. There's our quotient, okay? What we get after we divided by x. This one was x plus 1. Okay, so our quotient would be that. All right, now Nicole over here, she loves synthetic division. So she tried x minus 1 as a factor and used 1 here, carry down, multiply, etc. And she discovered that it wasn't a factor. Now I think that's a lot more work than doing factor theorem, but you know, she loves synthetic division. Maybe couldn't remember factor theorem at that moment, I don't know. Anyways, so she did it again. She finally got a factor of 0. Now the good thing is then she had the quotient already, just like Luke did. All right, now that being said, here's how I suggest I still want you to show this with factor theorem, but instead of trying number after number and, you know, keep finding out that the remainder was not 0 and have to do it again, here's what you should do. Grab your graphing calculators, okay? And what are we trying to put in? We're trying to put in x cubed minus 7x minus 6. I want you to graph that, okay? Pause your video and grab your calculator. Okay, so do you have that function entered in y1? Okay, x cubed minus 7x minus 6. Okay, then we want to hit graph. I think I'll go zoom standard, number 6, to just set the windows back to normal in case I had them weird in the last one. Okay, so it looks like we can see our x-intercepts pretty well here. And if not, you need to adjust your windows. But we do not, for what we're about to do, we don't need to know these x-intercepts exactly for what we're about to do. You just pick one of them, a nice number, that looks like it's going through exactly integer value of an x-intercept. Say x equals negative 1. I'm liking this one right here. because it's like 1 or -1. Okay, so x equals -1, and oh, and we already know that, don't we? See, that's how I would start this question, is I would pick that, then I would go back to what Luke did here and put -1 in to discover the remainder was 0. Okay, so that's how I suggest you guys start these, so that you don't have to have a misfire, I guess, on trying something that doesn't work. Okay, but you know, if you didn't have a graphing calculator, then this is how you would do it by hand. Okay, let's finish factoring that. So we have x plus 1 as a factor. That's our initial, what we tried. And then we have our quotient. There we go, equals 0. Because we want to, oh, we don't have to have it equal 0. This is just a polynomial function. So we could write it as p of x. Okay, now we just want to factor that remaining quadratic. 2 sets of brackets. X times x will give us x squared, multiplies to 6. Could be 6 and 1, could be 3 and 2. But 3 times 2, opposite signs because of this negative. We want to end up with a -1, so -3, +2. And there we go. That would be our final answer for that one. Great job. Let's look what's on the next page. Okay, example number 2. Consider the polynomial p of x equals yada yada. List the potential zeros. Okay, so remember, potential zeros using our integral zero theorem. As long as our coefficient in front here is a 1, then all of our potential zeros would be factors of 12. So we are going to list our PZs, our potential zeros, as plus or minus 1, that's a factor of 12, plus or minus 2, etc. You guys go ahead and finish that up, and then we'll see if we have the same answer, okay? Pause your video. Okay, there we go. We have all our factors. I want to give you a little hint when you go to write these. Once you hit 3 and then you go, the next one would be 4. These two are what multiplies together to give you 12. So then you're just matching them up after that, right? So if you're looking for the next one, you go, okay, what multiplies 2 times what gives me 12? And then you know your next factor is 6. And then this one matches with this one, right? Okay, a little easier to make list all the factors then, once you basically come back on yourself with the factors. Okay, express the polynomial in factored form. So this is where we have to do our factor theorem to show that something is a factor before we do synthetic division. So grab your graphing calculator. We're going to put this in y1. We're going to graph it and look at the graph and use a nice number to demonstrate that it's a factor, a nice x-intercept, okay? All right, so let's bring up our graphing calculator. Okay, so there we go, that's our graph. Okay, and okay, so we've got some nice numbers. Now probably some of you are thinking there already, well, I could write it in factored form just by looking at all my x-intercepts and putting them back into factors, and you're right, you could, but we're going to do it the algebraic way for when we hit example number 3, where our factors, or our x-intercepts I should say, are not integers. Okay, so that we kind of have to learn how to walk before we run here, and we need to demonstrate it algebraically. So looks like on here we have factors of -3, -2, 1, sorry, x-intercept, 1 and 2. Well, let's pick the nicest number to work with. Let's do that 1, x equals 1. Okay, and what we're going to do over here is we're going to demonstrate it. So with our factor theorem, so we'll first write this down. Our polynomial function down. Then we'll go p at, now we want to show that an x-intercept of x equals 1, which means we're putting 1 in for x, and using factor theorem, we should be demonstrating that the remainder is 0. So we should get 0 after we simplify this. Okay, so if we simplify this, 1 plus 2, 1 cubed, remember you have to do exponents first, right? So 1 cubed and then times 2, minus, and this is a square here, so, but it's 1 squared, so we're okay, even if I had forgotten that. Okay, and then add these together, 3 minus 7, -4, -8, so the -12 plus 12 is going to be 0. So here's what I want you to write when you have that. Therefore, x minus 1 is a factor, okay? And then we're going to do synthetic division in part 2 of this lesson number 5 video. Okay, see you then.